As a civilization, we have lived with storms since time immemorial, and we are only too well aware of the danger and the destructive power of certain types of storms. There are many types of storms, but in this video, we shall deal with a type that is meteorologically termed as a tropical revolving storm, or TRS for short. In various parts of the world, this storm has acquired for itself different names. In the west, it's called a hurricane. In the east, it's called a typhoon. And in South Asia, it is called a cyclone. Hello, I'm Captain Roy and welcome to my channel where I make videos about ships and answer questions. So if you would like to know more about ships, then stay tuned and come on board with me. Before the advent of modern science and technology, the physics and understanding of the weather and storms was largely mysterious. Other than the fact that they were fatal and appeared only at certain times of the year, nothing much else was known with certainty. But with the progress of scientific knowledge and technology, we now have a complete understanding of weather development and the behavior of storms. While this knowledge has not enabled us to prevent a storm from developing, it has given us the ability to at least predict one and to forecast its power and movement once it has started. Such information, once broadcasted, is extremely useful as it allows contingency plans to be made in advance in order to mitigate damage and loss of lives. Let's now dive into the physics of what exactly a tropical revolving storm is. Most of us are well aware of what a frictional force is, a gravitational force, and a centrifugal force, to name a few. But for the development of a TRS, another type of force is required. This force is known as the Coriolis force. Without this force, not only that a TRS cannot develop, but the behavior of the entire weather system on Earth in general will be completely different than what it is presently. So what exactly is the Coriolis force? Coriolis is an effect of force that was discovered by Gaspard Gustave de Coriolis. He was a French mathematician whose work and findings in rotating systems eventually led to it being applied in meteorology and was thus named after him. Basically, the Coriolis force is caused by the rotation of the Earth, which results in the deflection of air as the air moves over the surface of the Earth. In the northern hemisphere, this deflection is to the right of the direction of the air movement, and in the southern hemisphere, it is to the left. To demonstrate this, imagine a glider is flying in the air moving southwards from the North Pole towards the equator. On a non-rotating Earth, the glider will move directly south without any deflection. But on a rotating Earth, its path will be deflected to the right, and this is called the Coriolis effect. The same thing happens to air or wind, as we call it, as it moves over the face of the Earth. But before going any further, let's see what causes wind or air to move in the first place. The main cause of air movement is due to the difference in atmospheric pressure occurring in different areas over the surface of the Earth. In general, air flows from an area of high pressure to an area of low pressure. Atmospheric pressure is directly related to air temperature. Basically, cool air has a higher atmospheric pressure than warm air. Now let's see what happens when a parcel of low pressure warm air is surrounded by air of higher pressure. As nature always seeks equilibrium, the high pressure air will flow directly towards the low pressure area. But the effect of Coriolis is to deflect its path. When this happens, a circular air motion is created, and if there is enough high pressure to low pressure air difference to keep it going, then it could well result in the birth of a tropical revolving storm. Once formed, a TRS will usually strengthen and move along a characteristic path which is west-northwest in the north hemisphere and west-southwest in the south hemisphere, and then it typically recurves when reaching cooler latitudes. As it moves and strengthens, its wind speeds will increase, and in a mature stage it may even exceed 100 knots. When compared to depressions, a TRS is unique in that, unlike depressions, it does not have fronts, and at the eye of the storm, conditions are usually calmer. Tropical revolving storms are quite seasonal, forming usually during the warm months. They usually form about 5 degrees from the equator, where Coriolis force usually becomes significant enough and where atmospheric temperature and pressures are favorable. Over the sea, there are no obstructions, but when it passes over land areas, there are many obstructions. This causes it to gradually lose its power and its status to get downgraded from a storm to a depression. As the depression moves and fills, warm and cold fronts may develop, causing overcast skies and precipitation. But generally, the worst is over. A TRS can wreak havoc on anything that it passes over and can cause very high seas that can be disastrous even for well-found ships. Ships' navigation officers must always be on the alert of a TRS development in the vicinity, and its movement and closest point of approach must be plotted and ascertained respectively. Storm avoidance, mitigating strategies, and safety measures on board must be taken as early as possible to ensure that the ship has as safe a journey as possible.
Well, we've come to the end of the video. Thank you very much for watching, and I do hope to see you on the next one.